Hello students, today we are going to start chapter number 9, Mechanical Properties of Solids. Students, we all know about the concept of rigid body. If a body do not change its shape or size after the application of force, then such bodies are known as rigid bodies. That means rigid bodies cannot be deformed with the help of forces. Also, we know that a perfect rigid body is an imaginary concept. That means every real body can be deformed by application of the force. Now, here in this chapter, we are going to study about the elastic property of the solids. Now, I have written here that real bodies can be stretched, compressed, and they can be bent. Solid bodies are not perfectly rigid. So now, based on the elasticity, solids can be classified into three types. One is elastic body, the other is plastic body, and the third is partial elastic. Now students, what are elastic bodies? If a body is deformed after applying the force, but when the forces are removed, once again that body regains its original shape and size, then such bodies are called elastic bodies. Suppose if I have a spring, now when I stretched this spring from both the ends, that means force is applied, what will happen? The length of the spring will increase. But when these forces are removed, once again what will happen? The spring will gain its original shape and size. That means this spring is an elastic body. When the forces are applied, it is deformed. That means here its length changed. But when the forces are removed, once again it comes to its original shape and size. So such type of objects are known as elastic body. Now plastic body. Suppose the force is applied to a body, then what will happen? Its shape will change, means it is deformed. But when the force is removed, it remains in that state only. That means it is unable to come to its original shape and size. Such bodies are known as plastic bodies. Now about partial elastic bodies. This type of bodies gets deformed when the forces are applied, and when the forces are removed, they do not come to their original shape or size. They partially regain their shape and size. They do not regain their shape and size completely as original before the forces were applied, but they partially regain their shape and size. Then such type of bodies are known as partial elastic. Students, most of the objects which we used to come across are generally partial elastic only. Once again, a complete elastic body is an imaginary concept. Now students, example of this plastic body is a soft clay. Suppose you have a lump of soft clay. So if there is a lump of soft clay or a lump of soft plaster of Paris, a plaster of Paris mixed with water, then such type of bodies, they are plastic bodies, because on a lump of clay, if we apply the force, then what will happen? It will deform, its shape will change. Suppose if I applied the force from this direction, then what will happen? Its shape will change. And if the force is removed, then what will happen? It will remain in that shape only, it will not regain its original shape. So that is plastic body. So now students, what is elasticity? So elasticity is the property of a body by virtue of which it tends to regain its original shape and size when the applied force is removed. Then that type of property of a body is known as elasticity. Also, the deformation caused is known as elastic deformation. Means whatever the shape or size was changed, that is known as elastic deformation. Deformation means change in shape or size. Now about property of plasticity. If a body do not regain its original shape even partially after the removal of deforming force, then it is called a plastic body, and this property of the body is known as plasticity. Example is putty, mud, then POP, wet POP, etc. This type of bodies are close to ideal plastic. Now about partial elasticity. If a body partially regains its original shape when the deforming force is removed, it is said to be partial elastic. And the property of such body is known as partial elasticity. Students, the elastic behavior of materials play an important role in the engineering design. Engineering design means for construction of any type of structure. The elastic property is considered. Here I have given the example that when the bridge construction of bridge is taking place, at that time the elastic property of concrete, elastic property of the iron bars or iron rods which are used in the construction material, so their elastic property are considered. While constructing houses or buildings, the same thing is taken into consideration. Even the ropeway bridge, when the ropeway bridge are constructed, even at that time the elastic property of the ropes which are used is to be considered. Not only the bridges and the buildings, in the construction of any types of structure of any material, the elastic property of the material which are used are taken into consideration. Now, the elastic properties of materials like steel, concrete, etc. are taken into account for construction of buildings. Now, students, here this topic 9.2 is about elastic behavior of solids. Students, we know that the solids, they are made up of atoms, molecules or ions. So here these black color dots or small black colored spheres, they are nothing but the atoms or the molecules or the ions, and this spring is nothing but the bonding between them. It is a bond. So here a three-dimensional figure is shown of a substance or a body and their particles of which it is made up of. Now students, it is clear that if you apply the force at any point on this body, then what will happen? This body will deform, means its shape will change, its length, breadth or height may change. But when that deforming force is removed, once again it will come to its original shape and size. So that is the elastic behavior of this body. So here I have written the restoring mechanism can be visualized by taking a model of a spring ball system. This is a spring ball system. Here the balls represent atoms and springs represent intermolecular forces of a solid. Means it is a bonding between them, and bonding is due to the forces only. Robert Hooke, name of the scientist of England, performed experiments on springs and presented his law of elasticity, and he called that law as a Hooke's law. Now we will study about Hooke's law in our next lecture. Now about topic 9.3, stress and strain. Now students, what is stress? Here I have written, when a body is subjected to a deforming force, a restoring force is developed in the body. This restoring force is equal in magnitude but opposite in direction to the applied force. That is, suppose if we take an example of a spring only. Suppose one end of the spring is tied to this support or fixed at this support. Suppose this point is point O and this end point A. Suppose at this point A, suppose the force is applied in this direction. So this is an external force. So what will happen? When this force is applied, this spring will get stretched. Its length will increase. So in that case, what will happen? One more force will come into existence, which will try to bring the spring to its original shape or its original length. This force is external force which is applied, and the force which is developed due to this external force, that force is called a restoring force. Why it is called a restoring force? It is because it will try to bring the object to its original shape or size. So always a restoring force is developed in an elastic object when the external force is applied. So we can define stress in this way now. The restoring force arising per unit cross-sectional area of a deformed body is defined as stress. That is stress sigma. Here symbol stress is sigma. So stress is restoring force per unit area. Now about unit of stress. Students, we know that unit of force is Newton and unit of area is meter square. So unit of stress is Newton per meter square, or it is also known as Pascal. Symbol for Pascal is Pa. Now students, we know that if we know the unit or if we know the formula, we can easily obtain its dimension. And dimension of stress is m1 l raised to minus 1 t raised to minus 2. This unit and dimension of stress is same as that of pressure, because we know that even pressure, formula for pressure is also force per unit area. But remember, stress and pressure, they are not the same physical quantity. Of course, their unit and dimension are same, their formula is also same, but as a physical quantity they are different. Even their definitions are also different. Now you can see here in this figure, when the forces are applied at the two ends of this cylinder or a cylindrical wire, then the length of this cylinder is changed. Initial length before application of force, initial length was L, but when the forces are applied, the length changed and the increase in the length is delta L. So total length will be now L plus delta L. So this much increase was there when the forces are applied. So now here I have written that if a cylinder is stretched by two equal forces applied normal to its cross sectional area, the restoring force per unit area in this case is called a tensile stress. Word tensile is used for linear objects, and here we know that this cylinder is a linear object, and when the forces were applied, there is only change in the length. Now if the cylinder is compressed under the action of applied force, the restoring force per unit area is known as compressive stress. So students, tensile stress arises when the object is stretched by applying the forces. But if the forces which are applied in this way, then what will happen? The length will decrease. Here in this case length increased, so that was tensile stress. But if the forces are applied to compress the object, so in that case what will happen? The length will decrease. And so in such case the stress which arises is known as compressive stress. Now students, this tensile or compressive stress can also be termed as a longitudinal stress. That means one word. If you want to give a one word for this tensile or compressive stress, then we can say that it is a longitudinal stress. So students, it is clear that when the length of a body changes by the application of force, either length increases or length decreases, that is change in the length. So in that case the stress arises is known as longitudinal stress. Now students, here the cross sectional area is considered this is the cross sectional area. So here if the cross sectional area is A and the force applied is F, then stress sigma is equal to force per unit area. Now about strain. Now students, this strain arises whenever there is a change in the length, volume or shape of a body due to external force. So now let us define first longitudinal strain. Earlier we have defined longitudinal stress. Now we will define longitudinal strain. So students, according to definition, longitudinal strain is a ratio of change in length to the original length, and the symbol of strain is epsilon. This symbol epsilon is for the strain and here L is for longitudinal. So it is a longitudinal strain. So students, it is clear that when the forces are applied, the stress is produced in the body, and due to stress there is a change in length, and change in length to the original length, that ratio is nothing but it is a strain. So it is clear that strain arises due to stress. Unit and dimension of strain. Strain is a dimensionless quantity, because we know that unit of change in length. What is unit of change in length? Meter. What is unit of length? Again meter. Meter will cancel and it results in 1. 1 means a constant number. So strain does not have any unit, and so it does not have any dimension, because it is the ratio of the same physical quantity. Here also it is length, here also it is length. Now about sharing stress and sharing strain. Earlier we have studied about longitudinal stress and longitudinal strain. Now another type of stress and strain are sharing stress and sharing strain. Now students, you can see here a cylinder is shown here. Suppose the forces are applied along the tangential line. You can see here the forces are applied along the tangent. So in that case, what will happen? The length of this cylinder is not going to change, but the shape of the cylinder will change. Earlier it was completely cylindrical shape. Now you can see the shape changes a little. So in such type of case, the stress is known as shearing stress, and due to this stress, whatever the strain is arised, that strain is called shearing strain. So here only shape changes. In that earlier case about longitudinal stress and longitudinal strain, length was changed, but here length remains same, only shape of the body changed. Now students, I have written here, if two equal and opposite deforming forces are applied parallel to the cross sectional area of the cylinder, then there is a relative displacement between the opposite faces of the cylinder. You can see one force is in this direction, another is in this direction, and these are the forces applied along the cross section, that is parallel to the cross section. And so now these faces, earlier they were in this way, that is along this line, but now these faces they were displaced. Now there is distance of delta x between these two faces, and so we can say that the shape has been changed. So now the restoring force per unit area developed due to this applied tangential force is known as tangential or shearing stress. So here this stress is known as tangential stress or shearing stress. Here I have written that as a result of shearing stress, the strain so produced is known as shearing strain. This tangential stress is also known as shearing stress, and due to this stress the strain is produced, which is called shearing strain. So now students, here according to definition, shearing strain is given by delta x upon L, and that is nothing but it is tan theta. Once again, look here in this figure, that earlier between this point and this point, let me call this point as A and this point as O. It is a straight line, but after the forces were applied, we can consider this point A is here only, but this point O displaced with respect to A. So with vertical line, this displacement is delta x. And so if we take tan theta, because we know that here this angle is formed theta, so theta is delta x upon length. So students, we have written here tan theta is equal to delta x upon L, and that is nothing but is a shearing strain. But here we know that for a solid body, when we apply this type of forces, this angle which is formed here will be very much small. That angle is too much small to detect. So if the angle is very small, then in that case we can write tan theta is equal to theta. And so here I have written that usually this theta is very small, and so this tan theta can be written as simply theta. And so finally we can say that shearing strain epsilon s is equal to theta, because epsilon s will become theta. Now students, about hydraulic stress and volume strain. In first case, we have seen the change in length of a cylinder, and we called that stress which was produced as a longitudinal stress. Then in next, we applied the tangential forces, and due to this the shape changed, and that stress we called as a shearing stress. Now here about hydraulic stress. Students, when the forces per unit area, if the force applied per unit area of a given body is equal, then what will happen? The volume of the object will decrease, and that produces the stress called hydraulic stress. And so students, I have written here, when a solid body is immersed in a fluid, the forces are perpendicular to the surface locally. You can see in this figure also, the forces at each and every point of the surface of this body is perpendicular to it. At every point the force is perpendicular. So application of such forces causes change in the volume of the body. Only volume changes, shape will remain same. For example, if there is a sphere, its volume is V. Now when this sphere is immersed in a liquid, suppose it is kept at some depth in a ocean, at some large depth, so what will happen? Due to pressure, the force will apply at each and every point on this sphere, and due to that what will happen? The sphere will contract. Earlier shape and size of the sphere was this, but after, when it is immersed in the liquid, its shape remains same. Earlier also it was spherical in shape, now also it is spherical in shape, but the difference is now the volume of the sphere decreased. So definitely here there is only change in the volume. Shape of the body does not change, shape is still spherical only. Volume changes. And so this type of stress is known as hydraulic stress. Now students, the internal restoring force per unit area in this case is known as hydraulic stress, because definitely when the volume decreased, due to that reason the internal force will develop. That internal force is restoring force. And so it is clear that restoring force per unit area here in this case is called hydraulic stress. Now students, from figure, this force is applied force on the area of this object, and force per unit area is nothing but it is pressure. But due to this force on this body, its volume changed, and due to that what will happen, one force will be in the opposite direction, and this force is nothing but it is a restoring force. Due to external force, a restoring force is also developed, which is opposite to the applied force. And so this restoring force per unit area is nothing but it is stress, which is hydraulic stress. Now students, if we consider this applied force as positive, then this restoring force must be negative. As a magnitude is same, but the direction of force is opposite. In pressure, it is applied force per unit area. In pressure, it is applied force per unit area. And here in stress, it is restoring force per unit area. So I have written here, the magnitude of hydraulic stress is equal to the hydraulic pressure. Magnitude is same. So sigma V. Sigma is used for stress and V for volume because there is change in the volume. So sigma V is equal to pressure only, and that is equal to force per unit area. Now students, due to hydraulic stress or hydraulic pressure, a strain arises, and that strain produced by hydraulic pressure is known as volume strain. So according to definition, volume strain is defined as change in volume to the original volume. Students, earlier we have seen about the longitudinal strain. In longitudinal strain, the symbol was epsilon L, and in that case what was changed? Length was changed. So change in length upon original length. But here in this strain, volume strain, change in volume is there. So change in volume upon original volume is nothing but it is a volume strain. Now let us study about Hooke's law. It is quite simple. So topic number 9.4, Hooke's law. According to the statement, for a small deformations, the stress and strain are proportional to each other. Means sigma is directly proportional to epsilon, that is stress is proportional to strain. But what we have to consider here, for small deformations, means suppose if this is a cylinder and if I apply the forces, so for that limited amount of force, so that the change in length is also slight. That means deformation should not be very much large. So in such case, stress and strain are directly proportional to each other. But if the forces applied are very large, then we know that this change in length will also be very large. In that case, this relation cannot be applied because the deformation will be very large in this case. And due to that, what will happen? When the forces are removed, this object may not come to its original shape and size. Now, if this proportionality sign is removed, we have to put some constant. So here K is a constant of proportionality and it is known as modulus of elasticity. Means this K depends on the elastic property of the material of or a body. Now students, this Hooke's law means sigma is directly proportional to epsilon. That is Hooke's law is an empirical law. Empirical means the law obtained by doing experiments on various objects. So on the basis of experiment, this law was derived. So it is an empirical law and is found to be valid for most materials. That means all the substances or the materials, they do not follow this law, but most of the materials, they follow or obey this Hooke's law. Also, one thing we have to remember, as I told earlier, that this law holds good for a very small strain. Means if the deformation is not much large, if the deformation is very small, then only the Hooke's law is valid, and that deformation or a strain must be nearly equal to 1%. It should not be more than 1%. Otherwise, the law cannot be obeyed. So students, I hope you understood about stress and strain.